Now we're going to look at one of three ratios we'll look at in this course, and that is the tan or tangent ratio. So, as we already discussed, right triangles have three sides, one of which is the hypotenuse. We've talked about that. There are two other sides, which are the opposite side and the adjacent side. So, the hypotenuse is the longest side of your triangle, of your right triangle. And it's always across from the right angle. So remember, that means it's not touching the right angle. The other two sides are labeled according to your angle of interest, which we call the target angle. So according to whatever angle you're considering your target angle, the opposite side is the side that's not touching the target angle. And then the adjacent side is going to be beside the target angle and not the hypotenuse side. Okay, so this asks us to label the three sides of our triangles according to angle A. So angle A is our target angle. Our hypotenuse is across from the right angle. So here it is here. The opposite side is going to be across from our target angle. I've used the symbol theta. Often we use that to talk about our target or unknown angle. So opposite is going to be over here then. And then adjacent is going to be this side right here. So it's touching our angle of interest and it's not the hypotenuse. Okay, next one. So this angle A here, this is our target angle. And then in the third one, our target angle will be right here. So pause this video and try labeling those two triangles. And hopefully you had a chance to do that. Let's do that together now. So over here, across from our right angle is our hypotenuse. Our opposite side is the side not touching our target angle, and adjacent is touching it and not the hypotenuse. And last triangle here, we have our hypotenuse over here, across from the right angle, our opposite right here, and our adjacent right here. And we're going to start talking about the ratio of those different side lengths. But before we do that, I want to do the following exercise. So what I'd like you to do, this first one's been measured for us, and I'm just going to check if on my printed sheet it actually makes sense. But we have three triangles here. Oh, it's pretty good. We have three triangles here. Each of them is just a scaled up version of the other one. So all three have a target angle there of 35 degrees. And what I'd like you to do is take a ruler and measure your opposite and adjacent side relative to this 35 degrees for all three triangles. Once you've done that, go ahead and complete the chart on the next page. So it's already been done for our first triangle. So you're going to put your measurements in here that you find for your opposite and adjacent sides. And then what I'd like you to do is calculate the ratio of opposite over adjacent. So take your opposite side length, divide it by your adjacent side length, and then you're going to put your decimal equivalents in here. So give that a try, pause this video, and then come on back. Okay, so you should have had a chance to measure your triangles. I measured mine as well on paper. I might have got slightly different answers from you. That's okay. It should work out. I measured 5.7 and 4.0, and then 8.7 and 6.0. Okay, so filling out the chart then, on triangle 2, our opposite side is the 4.0 centimeters. And our adjacent is 5.7. And in the largest triangle, our opposite side would be 6.0 centimeters. And our adjacent is 8.7. Okay, so now let's look at the ratio. So opposite over adjacent then is going to be 4.0 over 5.7. And that gives us a decimal equivalent Very close to 0.7. I guess let's go out to 2. So 0.70. That first one, 2.8 divided by 4 is exactly 0.7, so 0.70 again. And then our third one, so opposite over adjacent, is 6.0 over 8.7. You can write centimeters in there if you want. The centimeters would cancel out. And so if I round to the nearest hundredth, I'd get 0.69. And so hopefully what you can see, 0.69 is very close to 0.7 and likely reflects just very small differences in measuring. But we end up with the same ratio. So even though our triangles are different sizes, because they have the same angle, the ratio of the opposite over adjacent is the same. And so we call this ratio of opposite over adjacent the tangent ratio, or often we just call it tan for short. So tan of any angle, we'll call it angle theta, is the opposite side, the length of the opposite side, divided by the length of the adjacent side. So we learned that when the angle was 35 degrees, our ratio was about 0.7. If on your calculator, now you have to be in degree mode. Most calculators default to degree mode. On my calculator, I see a little DEG up top, or you might see a little D. If you don't, you might need to look at the manual or look online to find out how to get it in degree mode. Um, if you have a sharp calculator like mine, I have a DRG button, which allows me to change through the modes. So when you're in degree mode, if you hit the tan button, so you do tan 35 equals, you'll get an answer like this here. So that is telling you tan of that 35 degrees, that ratio is always, and it's more specific than ours, more precise than ours that we estimated, but it's always 0.7002075538. So that tells you what the ratio will be anytime you have that target angle of 35 degrees. And your calculator has these ratios stored for all of the angles. So you can punch in any angle and it will give you the ratio. So go ahead and try your exercise 3 and then come on back to the recording if you want to do that one together.